Hi, my name is John Ognisty. This is Lab 7. So here's exercise 1. We get this op-amp circuit. V minus is equal to Vn because Vn is V plus. And then we do a voltage divider equation to equate V minus and V out, which also equals Vn. Gain is V out over Vn, so we do V out over that equation, which ends up canceling out, equaling R1 plus R2 over R1, which is equal to 1 plus R2 over R1. Here's exercise 2. I basically just set up the 3 pins in the serial monitor, reading the pins, printing them, delaying 50. Easy. Processing code, I just set up a new column, set up the legend to follow, made a new variable, made it print. Yeah, and so here's the circuit. It goes in the potentiometer and into the op amp as it is supposed to. So here we go. Here's what happens when we run it. There's a point where Vn's at 0 and V minus and V out are just under 2 volts. And then as we increase Vn to that point, then they all start following each other until the very top where the Vn is just slightly higher. I believe that's just due to internal resistances within my equipment. And below this, this is the saturation point of the op amp. And this is based on the fluctuation between Vs positive and Vs negative, which is 0 and 5 volts. In 350, we would do a lot of problems assuming that it was -5 and 5. So the saturation point would be 0, but here it should ideally be 2.5, but I believe due to my just equipment and the imperfections, it has ended up just below 2 volts and just stayed there consistently. 3, yeah, all I did was added another pin, basically another thing for it to print. For this, I made another new row, another new variable, and it prints more now. So now we got our resistor coming out of the potentiometer going to V minus, and we got this voltage divider over here that makes this constantly 2.5. And then we got the resistor going from V minus to V out, and these are all brown, black, red, and this is brown, black, orange for 1 kilo ohm and 10 kilo ohms. So let's get this thing going. Here's what it looks like. Let me set it all. Oh, that's going up. So here's all the way down to 0. So the difference between V in and V minus is just the voltage drop across that resistor after the potentiometer. And as we see, when it goes up, the saturation point is this constant 2.5 volts from the V plus. And that is when V out switches from, that's when it inverts. That's the point that V out goes down, as opposed to when this is below 2.5, V out's high. When it's above, V out is low. Yeah. Here's exercise 4A. We're given this op amp circuit. V minus equals V plus, which equals 0 volts. Vc equals negative V out because this is 0. Whatever voltage goes across the capacitor is just negative that. So the current before is this, the current over the capacitor is this. They're the same, so we set them equal, and then we can integrate, and it ends up equaling this, which is a time integral of V in. And here's another method of doing it, nodal analysis. These equal 0, simplifying to this, and then you plug in ZC, and it simplifies out to this. All right, this is the demonstration of exercise 4. The Arduino code is the same. The processing code is the same. There's a new resistor, 4.7 kilo ohms, and a capacitor in the place of a resistor, 10 microfarads. So then we run it. We get this. Very similar as before. Similar concept. The V in and V minus follow each other. And then as they cross the 2.5, it's an inverter. So it takes place, the V out goes below as this goes above, and the V out goes back above as that goes below. And as you see now, it takes a little bit of time. This is because V out is a time integral of V in. And also this is demonstrated when you slightly increase in this area, and this increases and then goes back down slowly. That is due to the nature of V out being a time integral of V in.